Alright, so I think this is recording. We are looking at Scale Packet 5, which is exponential and logarithmic functions, and in Scale 5G we're solving equations using properties of logarithms and maybe the definition of a logarithm. Let's take a look at what we have here in this problem. Um, on the left hand side we have a logarithm, on the right hand side just a number. So we could try to rewrite this 2 with a log base 7, log base 7 of 49, but it's probably just easiest to convert this log form to exponential form. The base is 7. A logarithm equals an exponent, so the exponent for this base is 2, and that equals this argument, and we can see that we have a quadratic equation. And we're very good, hopefully, at solving quadratic equations because you should be familiar and know what the quadratic formula is. You could also complete the square, and hopefully we'll be able to factor this. But factoring doesn't always work because sometimes you can't factor it. If we subtract 49 from each side, we'll get it in standard form. And we do see that we can factor this. So we've got x minus 10, 10, and x plus 5. And this yields possible solutions to this equation. 10 and negative 5 are possible solutions. But we have to make sure that when we plug these in that it's not the log of a negative number. So if you look at x squared is 10 squared, that's 100, minus 50 minus 1, well, that's definitely a positive number. And if we plug in the negative 5 squared is 25, and the negative and negative would be plus another 25 minus 1. So yeah, those are both, and you can see 49 and 7 squared is 49. So we can also see that these are both definitely solutions to that equation. All right. Now this one is a little more difficult. It's an exponential equation, but the term of interest, the term that I want to get by itself, is down here in this denominator. So this equation can be looked at as a proportion. On the left-hand side, we just have a fraction, and on the right-hand side, I can write that as a fraction. And one technique to solve proportions is to cross multiply. And students seem to like that. They seem to be very good at cross multiplying. So when I multiply along this diagonal and then I multiply along my other diagonal, I can write I can set the two products equal to each other. So the 6 times 1 is 6, and negative 1 times this guy, that negative, I could have just changed the order of the subtraction. It's the same thing as multiplying it by negative 1. So let's do that. Alright. So on the right hand side I have two terms, and the term of interest that has my variable is this first term right here. So I need to add 4 to each side. So I've got 10 is equal to e to the raise the x minus 3 power. So I need to get that exponent down to where I can isolate that x. So I need to take the natural log of each side because the natural log is base e. So if I take the natural log of the left-hand side, I have to take the natural log of the right-hand side. And because these are inverses and this is base e, because these are the same bases, this is going to be x minus 3. But if you don't see that, by the product rule, this x minus 3 comes out in front. And the natural log of e, well, remember the natural log is an exponent, and e to what power is equal to e? Well, e to the first power. This guy is just the number 1. So now all I have to do is add 3 to both sides to get this term x by itself. And I have 3 plus the natural log of 10. If I go to a calculator and approximate that to 3 decimals, what do I get? 5.303. is the approximate answer. 3 plus natural log of 10 is the exact answer. So let's plug it in on the left-hand side here and see if this ratio does equal -1. So if I've got 6 in the numerator, and in the denominator, I need parentheses around it. 4 minus e raised to, well, my previous answer, minus 3. And I'll close that parenthesis. I should get -1. Yeah. All right. So I'll do these word problems on separate videos. So hey, I hope that helps, and I'll talk to you in a minute.